Good evening, and thank you for joining us at the third event in ILR Cornell's Future of Work series. I am Professor Louis Hyman. I'm a professor of economic history and the director of the Institute for Workplace Studies here in New York City, which is the home for Cornell's research on the future of work. And as you probably know, ILR is not the only Cornell game in town. Currently, Cornell is building a new campus focused on technology on Roosevelt Island, which we hope to start opening next year. And so part of the impetus for that campus has been the transformative role of technology in our everyday life, which you probably have noticed that there is technology in our everyday life. And this technology, what's interesting about it is that, of course, some of it is top-down. It's Apple selling us iPhones. But it's also been this rediscovery of personal invention, this rediscovery of the wonder of making things, especially electronic things, from the ground up. And if you wanted to blame someone from this, which I hope you do, I hope you point someone out in the crowd, one of this crowd's is this guy right here. You should point to him, Mark Frauenfelder, who a little over a decade ago was the founding editor of Make magazine, which became the DIY technologist's Bible almost from the very start. Make magazine became the origin for nearly every other kind of make circulating in our society. Maker fairs, maker labs, maker bot, maker blah, 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 blah. All the makers. And so in many circles, making is not just a hobby. It's not just tinkering. But it's almost like a political movement. A movement that is about turning capitalism on its head, turning production on its head, with distributed possibilities for personal manufacturing. And so Mark is here tonight to talk about its origins, its future, and what it means for work. Now, he also runs something on the side called Boing Boing, which if you've heard about it, you're really excited. If you haven't, you think that's very strange. And he also runs the research. He's the director of research at the Institute for the Future in Palo Alto. And he also wrote a bunch of fabulous books, but I don't want to talk about any of those because I don't want to go to his head. Now, before we go to Mark, we should also welcome Niti Parikh, who is not just an architect, but is also the creative lead at Cornell Tech's own Maker Lab, which is currently housed at Google, but will be on the aforementioned Roosevelt Island when it opens. And she will help kick off the Q&A as someone who is an expert in the world of makery. Before we start this program, I'd like to also thank everybody online, the hundreds of people online. You made a good choice by avoiding the rain, but a bad choice by avoiding the wine. We have lots of free wine here. And I'd like to thank Cornell Alumni Affairs and Development for co-sponsoring tonight's event, as well as the Cornell President's Circle members who are joining us tonight, and for supporting programs like this at our university. So please give a warm ILR Cornell welcome to Mark Frauenfelder.
Thanks, everybody. So I wanted to start this by going back and looking at a little bit of maker history. So these are farmers, and if you can look in the back of the workshop there, or this barn, you see lots of machinery, and that's very typical of farms at the time. Most farms had their own workshop, and the reason that they did was because they needed to fix all the machinery that they had, and they had to invent new machinery. They were very innovative. They were far away from urban centers, so they were really self-reliant about making those kinds of things. Interestingly, in 1900, 80% of Americans either lived on farms or they worked on farms and lived in those areas. And today that number is greatly reduced. Here you can see this is a kind of an interesting conveyor thing. I'm not exactly sure what that is, but they had these. I was interested in looking at farmers as makers, so I started looking at some of the literature about farmers as makers. And this is a catalog that sells machinery. And this is just a couple of pages from a book of like a catalog of hundreds of pages thick of all these little parts and things. I mean, you could like rebuild civilization after the zombie apocalypse with a catalog like this. All these pulleys and machines and things like that. So as farmers do, when they're done working for the day, they had the skill set that they had acquired, making things using their hands to put things together. And so along comes this guy, Hugo Gernsback, who realized that he had a potential audience for magazines. And so Hugo Gernsback, he's best known as the father of science fiction with Amazing Stories magazine. But he also published all of these other interesting magazines in the very early 1900s. The Electrical Experimenter in 1913, The Experimenter, Science and Invention, Radiocraft, Everyday Mechanics. This is actually a picture of Hugo sitting there in a beautiful upholstered chair looking at the equivalent of a widescreen television set. That little hole there is a cathode ray tube, and it's remote control. You can see his little control that he's holding in his hand there. He was also the inventor of an early version of Google Glass. Here he is in 1963. So I was interested in what Hugo Gernsback's magazines were about and the kind of projects that were in them. It was really surprising that they were very similar to the kinds of things that you would find in Make magazine today or websites like Constructables and stuff. These are all articles from, these are like 100 years old, these articles. Wireless transmission of power, free electricity from the wind, a radio-controlled model boat, electricity to prevent future fuel crisis, utilizing burnt-out lamp bulbs. That is like, those could actually be the cover lines for Make magazine today. Pretty amazing. And so then when I actually started looking at the magazines themselves, I saw some really remarkable coincidences between then and now. So this is a parabolic microphone so that you can listen to nature sounds that focuses the sound so you can hear things from a distance. And we had a very similar project in Make magazine. This is a parabolic microphone that you can make from parts at a dollar store. That's a small umbrella. You can see a paint roller. You can see a little cell phone wireless or a wired headset there. And it works really well. And this is kind of a goofy radio hat back in the days when everybody was wearing radio hats. And here's one that we had in an issue of Make magazine. It was a synthesizer, but still the same idea. You had knobs and buttons and lights going on and things like that. I really love this old project from a 1961 issue of Popular Mechanics because it's not a typical go-kart project. Typically, the go-karts would have lawnmower engines in them, but this was a battery-powered engine. And when I looked at that, it reminded me very much of a project we had in Make magazine. This one, down to the red wheels, except he went backwards and he's using a gas-powered engine. And I like the way that he's being safer and less safe at the same time. And here we have a suitcase-sized power cycle. And the artist struggled a little bit with that to make that. Look at the size of that suitcase that he has there. But it really is a little motorbike that you can make. And we did a little suitcase-sized motorcycle ourselves. That's a 36-volt electric drill that you see on the back of that scooter. And we built it. We always replicate all the projects in Make magazine in our labs. So we built one, and I took it into the parking lot. And I did it, and it had so much low-end torque that it just scooted out from under me, and I landed on my butt. And it took me a few times to get used to it, but once you do, it's like amazing. It really zips along. I love this one, teaching her wireless. You can tell he's really interested in teaching her Morse code. But the fact of the matter is that making, I've found to be like an amazing group activity. And there's a lot of couples. If you go to Maker Faire, you see couples, you see families, you see groups of friends. It's a great way to really like learn from each other, participate in something, share your skills with other people. So the Maker move, as I was reviewing all this literature, I saw like this trend where making was getting better and more accessible. And then we hit something kind of around the 70s where we hit kind of like a dark age of making, I would say. And these two issues of Popular Mechanics really like show the stark difference in how things changed. If you look at this issue from 1973, it's all about like hands-on doing things yourself. So it's like complete car care guide, how to wire a yard light, how to silence squeaky floors, how to hang shelves, things that you can do. And then you look at this 2000 issue of Popular Mechanics, and there's nothing in there about making things. It's like the world's tallest building. No one's going to make the world's tallest building in their backyard. The fastest PC you can buy. The old magazines used to have all sorts of like computer projects of like making your own microcomputers. This is about buying one. And then brain implants. Nobody's going to be doing brain implants at home either. Popular Science in 1970 and 2000, we see the same kind of difference. Look at that funky, really cool car that this guy has here called the Box. Far out fun car. That looks really great. And again, lots of articles about taking care of your stuff, fixing, making, modifying, repairing things that you own. Again, in 2000, we have something called The Revolution Under the Hood. And there's this really good book by Michael Crawford called Shop Class as Soulcraft. And he said, like, modern cars, when you lift the hood, the thing that you find under them is another hood. They're like inaccessible. You can't do anything to them. Again, world's fastest computer chips. So what happened? Why did we see this decline? Why did people stop making things? Well, here's my theory. So in 1954, if you wanted to buy a color television set, it was over $1,000 in 1954 money. And if you adjust that for inflation, it's like close to $10,000 to buy that TV set. So that was a significant investment of money. And when that TV broke, it was up to you to take care of it. There were no stickers that said no user modifiable parts inside. You actually took the perforated board off the back of the television and you pulled the tubes out of the TV. And I remember my dad doing this when I was a kid. You take the tubes down to the local drugstore and they would have a machine like that. And you can see that you can plug the tubes into the thing, and a little needle on a meter would tell you whether or not to replace the tubes. And then you could open up the little cabinet below, buy the tubes you needed, and plug them into your TV. And you were like had a sense of ownership in that TV. And this, I just had to add this little thing from a December 1962 issue of Popular Science. This guy is saying that when he takes his cathode ray tube to the shop for repair, he puts it in the seat with a seat belt on it. And that explains why cars in 1962 had seat belts. So moving to 2017, a TV set costs $140. That's like, adjusted backwards, it would be like someone in 1954 spending $17 in 1954 money. So when this TV breaks, what happens? That's all you can actually do. I mean, if you wanted to fix it and take it to a repair place, if a repair place exists, a local one, they're going to tell you that it would cost them more to just like diagnose the problem than it would be for you to buy a new set. And even if you wanted to like open it up, you would find that a lot of the enclosures are glued together rather than screw fasteners that you could open yourself, so you couldn't even get to it. If you were able to like rip the glued enclosures apart, you would just find little tiny surface mount components. You wouldn't find tubes anymore. And so you couldn't even fix the TV by getting to that level either. So people started to get used to the idea of spending money to solve their problems, buying solutions to their problems, as opposed to inventing solutions to their problems and being like those farmers who had to be self-reliant and come up with ways to make things work. And I think that was like a bad thing. It makes people become more passive about the design world around them rather than being active participants and contributing to it and helping to make it for themselves and their families and their communities. But all along, while we saw this decline in making in the mainstream, there were kind of some underground subcurrents of making. And I think that the world of hippies and punks were really kind of keeping that maker spirit going. There was the Whole Earth catalog that I think the first issue was 1967 or 1968 that Stuart Brand put out. And it was kind of a catalog or manual for rebooting civilization. And it was like a guidebook for people who wanted to get back to the land, move on communes, learn how to grow their own food, learn how to make their own shelter, new modes of transportation, reviews of tools, even things, even personal computers and technology were covered in the Whole Earth catalog. And then the whole punk rock movement was about short-circuiting the record industry so that you did not have these barriers that kept small bands from being able to tour or get their music out in the world. So they had cassette distribution subcultures, new networks for touring, a really huge zine culture around punk music, and it was very much a DIY spirit. And in fact, the zine world itself was a huge part of the maker movement, I think. That's kind of how I got my start. I started Boing Boing as a print zine in 1987, and these are some of the zines from my collection. They were really cool, like thanks to desktop publishing and the ubiquitous corner photocopy shop, people were able to make their own magazines. They had really fun ones, like there was one called The Optimistic Pessimist for Pez collectors, or 8-Track Mind for people who just wanted to collect 8-track tapes. And everyone would send their zines into this guy in upstate New York who would review the zines, and was kind of like, he had a zine called Fact Sheet 5. It was like the Yahoo of the zine world, and I would go through every issue with a highlighter and find the zines I wanted and send them a copy of Boing Boing, and they would send it to me. Very much part of the DIY spirit. And a lot of people that I meet in the maker movement at Maker Faire now are either old hippies, aging punks, or Gen X zinesters. They've all gravitated towards it. And so I think that all of these folks have helped create a second phase of making, and it's one that's really interesting. The earlier phase of modern making, which I would say starts around the year 2000, was about people making things and then sharing their plans online on how to make them. But then you have this other phase where it's about people who are making tools and systems for everyone to become makers and make really cool stuff. So it's kind of like meta making. Makers are naturally interested in making things, but they're also naturally interested in creating systems and methods to get things done on a higher level. And so what we're looking at with this maker movement, the modern maker movement, is the end of organizational advantage. Imagine being able to make something that is like a high-end piece of consumer electronics. Typically, you need a large organization that has all these departments. So research and development, design, all those things to make something happen. Very expensive, large capital investment to do that, large employee workforce to make that all happen. But actually, all of these things are now available in a very widely distributed but accessible network, so that you can take what you need. Some of the things are very low cost, some are even free, and you can really, if you just have an idea and you're passionate about it, you can make it, either for personal reward, or if you're interested in actually like making a product and selling it, you have access to this stuff. And so the first thing I wanted to talk about was research and development and how things have changed. Say you wanted to make a remote control lawnmower 15 years ago or even 10 years ago. It would have been really tough to do that. You can't really go walking around your neighborhood knocking on doors saying, have you ever built a remote control lawnmower before? Can you tell me how to do it? They would think you're crazy because none of them have. But if you go onto Google and you type in remote control lawnmower, and I just did a Google image search, you'll find 1,000 people around the world who've made their own. And not only can you find them, but you can get in touch with them. Makers are very friendly, warm, welcoming people who will be more than happy to share with you how they made the stuff that they make. That's one of the really cool things that I love about the maker movement, is how it's a gift economy where people share things with really not expecting to be paid back in any way other than just like feeling like they're part of this movement to create cool things. About 15 years ago, there was a Usenet group called alt.coffee, and they were really obsessed with nailing down all the different variables required to make a perfect cup of espresso. So there's like the freshness of the grind, how tightly you tamp the espresso into the portafilter, the temperature of the water. There's 5 or 6 different variables. One of the trickiest is the water temperature, and that can make a huge difference in the quality of the coffee. So these guys were saying, there's a 40-degree swing in the boiler, in the temperature of the water when the little indicator light says it's time to pour coffee, and that could, what can we do about it? So some guy who was working for the Bureau of Standards borrowed a temperature control system from the office and brought it home. It's called a proportional integral derivative temperature control system. And he attached it to his espresso machine. And so the red line that you see there is a typical bimetallic thermostat. The blue line is using this PID temperature control system, and it locks the temperature into 0.1 degrees variation as opposed to 40 degrees. So it's 400 times more precise. That dip there is what happens when you pull a shot and the pressure is reduced, but that's fine. You see it jumps right back up the temperature. So immediately this whole group of people were like, this is the coolest thing in the world, I love it. And so they started like adding PID to their espresso machines. They even started selling kits. That's my espresso machine, and that little thing attached to the left is my PID temperature control system. It's like, I love having that variable nailed down. So you would think that the espresso manufacturers who've been making espresso machines for over 100 years would have added this thing a long time ago, because PID temperature control has been around for quite a while. But they didn't do it. But once it started like bubbling up in this maker world, then they started doing it. And now all the fairly high-end espresso machines have PID, and they act like that they invented it and came up with it. But the R&D that you have access to by just going online and asking people and joining these communities of interest and communities of practice is incredible, and there's never been anything like it before, and we're going to continue to see amazing innovation because of it. And this is kind of what I am calling open R&D, where you had these people who were just reinventing the wheel, they were disconnected, and once they finally started linking up, either non-physically by going online or by going to maker spaces, the innovation has jumped. Everything from like cigar box guitars to drones to robotics, this effect is taking place. And there's maker spaces all over the world, and I'm sure you're all familiar with them, but you can go to hackerspaces.org and just type in anywhere in the world and you'll find a makerspace there for you.
Mark, can you tell us what a makerspace is?
Oh, yeah, sure.
Not everybody knows about Make Magazine or Maker.
Okay.
No.
Yeah.
We're not in California.
Okay. Yeah, that's fine. So a makerspace is a little bit like a gym membership. You pay a small monthly fee to go into a physical space that has all of the machinery and tools that you would need to make things. Soldering irons to make your own electronic circuit board projects, band saws, 3D printers, laser cutters, all those kinds of things, and you kind of share the cost of them. And really the best thing, the killer app of makerspaces is the other people that are there, because then you can like share knowledge. And I'll have an example later on of a great example of people getting together in makerspaces to doing that. And then they have a level up as they have something called Tech Shop. There's a chain of tech shops. There might be one in New York. I'm not sure.
It's opening this fall.
And they have like great classes and really high-end 3D computer numerical control milling machines and things like that can make really precision manufactured parts for you or prototypes for you. There's a lot of people who've used Tech Shop to actually go on and launch companies based on the things that they made. So CAD software is a really important thing because you need to design your parts and feed them into all of these new low-cost desktop manufacturing machines. When I started out as a mechanical engineer in the 80s working at Memorex, and we designed these disk drives that were 100 megabyte capacity and weighed 70 pounds. And I started the first year I was an engineer, I used a drafting table with a pencil and a T-square. And then the second year we got CAD systems in, and we were in a room, it was like an air-conditioned room, and we had these wireframe models that we would put together, and it was like $50,000 per software seat, plus I don't know how much, but it was like quite a bit of money per hour of using it. Some guy from the software company would come with a machine and stick it into the computer and read how many hours you had used, the workstation had been used and the software had been used, and send a bill to Memorex. And now you can get like Google SketchUp or other CAD software programs for nothing. They're free. And I'm not kidding, they're like 10,000 times more powerful than the CAD system I was using. And as a result of that, you're getting tons of amazing 3D models. And what's more, people are sharing them online on these online 3D model repositories, so that you can just go to like thingiverse.com and type in soap dish, and you'll see a 3D soap dish, or chain linkage, or gears, or eyeglasses, or toothpaste squeezer, or a vise. And you can download the model, and you can just plug it into a 3D printer and have it spit out. Or you can download it into Google SketchUp or one of those other 3D programs and change it so that the eyeglasses have a different shape, or the vise is twice as big, or the soap dish is a different size, or the lip around it isn't as big. So you have this tremendous library of projects that people have just uploaded for free. Just grab them and change them the way you want, and have your machine spit it out. The other cool thing is the way that the internet has become like this indexed surplus store. So if you want a part, it's really easy to find parts. When I was an engineer, it was really tough finding the exact bushing or valve or motor that you wanted. And now you can just go online. I needed some photoresistors, which are resistors that change the value of resistance depending on how intense the light is that's hitting them. And so I went and I looked on eBay. You can buy 20 photoresistors for $2, and the shipping is free. And I received this little package, a box from China. And how can they make any money at all sending you 20 photoresistors from China for $2? Something is odd about that. But anyway, Alibaba, are you familiar with Alibaba? It's a place where you can buy parts, and you can also specify custom parts. A guy I know, Chris Anderson, who was the editor-in-chief of Wired magazine, became interested in drones, flying drones, and so he started a little side business and called 3D Robotics. And so he was selling kits, little drone kits, and he needed motors for the kits. So he found someone on Alibaba, and he said, I'm making 100 kits. And they said, okay, 100 motors, custom motors, $1 per motor. He said, okay, thanks. And he said, but wait, if you want 5,000 motors, 17 cents a motor. So he said, I'll take 5,000. And luckily he made enough kits, and he sold out of the kits. And he ended up quitting Wired magazine for 3D robotics. So prototyping is amazing too. I'll just share one more story quickly about being an engineer. When I designed a part like a base plate for the disk drive, I would have it, I would make the model on a floppy disk, drive it across town to a model shop, and this guy would stick it into his computer and then generate the tool paths for it. He had all this equipment, and he'd say, like, come back in 2 weeks. If it was a rush, it could be a week. So it would take that long. I would come back, get it, bring the part, and there's always going to be a problem, like the holes aren't lined up, it won't fit properly, so I'd have to redesign, change it, take it back. It's this iterative process would take a long time to do. But now if you have like a 3D printer or a laser cutter or a 3D milling machine in your facility, you can like make your prototypes really quickly and make those mistakes quickly and early on when mistakes are inexpensive to make, because the mistakes are going to be inevitable. So get those mistakes out of the way early, and that's like some of the power of what you can do. So those little green things are little plugs that I made for some furniture like this. See how these rectangular legs? I have some patio furniture, and it's 30 years old, and the little plastic plugs at the bottom had disintegrated. So I printed some out on my 3D printer. That little piece of wood is cut out from a Glowforge laser cutter that's coming out. Those chairs are from a router called a ShopBot. And these are all things that are, the 3D printer is like $299. The Glowforge is between $3,000 and $5,000. The ShopBot's about $10,000. This circuit board was milled out with something called the other mill. It's a couple of $1,000s. And so you really, it's kind of like the way that before, if you wanted to have like a program, a show, like a video show or a audio show, you would have to have an FCC license and $1 million worth of studio equipment and satellites and everything. And now you can have like a $300 laptop and a microphone, and you can have a podcast or a YouTube show. It's kind of like that for manufacturing. You can have this like stuff that costs a fraction of what it used to cost, and you can make these amazing prototypes. The Arduino, who's heard of Arduino before? Okay, what it is it's a little printed circuit board about the size of a credit card. It costs $30, and it lets artists and designers add electronic interactivity to their projects without having to be an electrical engineer. It takes inputs from the world like temperature, pressure, light, vibration, a press of a button, a signal from the internet, and then depending on a program that you write, a simple program, it will take that data, do something to it, and then give you an output signal. So one thing you could do is you could make a little device with the Arduino where you stick a humidity probe into a house plant, and when the soil dried up enough, the Arduino would record that and then send a tweet. The plant would have its own Twitter handle and it would tweet, "Water me." And so you can, so just imagine like before, if you wanted to make something like that, you would have to have an electrical engineer help you. You'd need a lot of support. Now it's very simple. There's a huge code base online on Google where you can like make anything, do anything with an Arduino. This is a cool thing. A guy who's not an engineer made a reverse geocache puzzle box. And so what he did, he gave it to some friends who were getting married, and they said, and they tried to open it up, and they said, it won't open. He said, well, push that button. So they pushed a button, and it said something like 300 1/20. And they're like, what does that mean? He said, well, get in your car, drive a little while, and push the button again. So they drove, and then they drove, and it said 303 2/20. So they thought about it for a while. They drove again. What they realized was that first number was how many miles away they were from a certain spot. The second one was how many button pushes they made out of 20 that they had before the box would lock up forever and never open again. So they eventually like drove and they opened it up and there was like a little gift inside the box. So inside it, there's an Arduino, a GPS unit, a battery, and then that's a little servo motor, the kind of thing they use in remote control airplanes to raise and lower the elevators on a wing. So all it's doing is like reporting where it is from the GPS unit, and the Arduino is saying, are we there yet? And if it is, then it says, okay, open the latch, and that little servo pulls that dowel there off the screw eye, and then you can open up the box. And so this is something that the inventor, Michael, is allowing anyone to make for free. And if you want to like make it commercially, he's happy to license it to you. This is something that I made with the Arduino because I have 3 cats. We have 3 rescue cats, and they shed like crazy. They love to jump on furniture, and then the fur just drops off of them. And so I made this thing. It's got a little motion detector. And so when the cat jumps on the furniture, the little monkey starts clapping the cymbals, and the cat seeks a quieter resting place. And this is another thing. I found this patent where a guy was talking about mixing industrial chemicals in 55-gallon drums, where you have 2 layers, like a solid, a very thick viscous layer, and then a thin layer. And he realized by rotating the barrels every 24 hours, those 2 liquids would mix together. And so I decided to do something similar with peanut butter, because when I make peanut butter sandwiches, when you open up a new jar of natural peanut butter, there's that oil on the top, and you're trying to stir that concrete solid at the bottom, and oil's all over the place. So what this does is, it's Arduino powered. Just every 24 hours, it just turns 180 degrees. And then the oil at the bottom slowly, since it's less dense, works its way through the solid. And you do that after a few days, the peanut butter is well mixed. I think everyone should have one of these in their kitchen. And then Raspberry Pi is similar to the Arduino. Again, $30. Well, they've actually introduced like a $5 version with Wi-Fi and everything. It's amazing. It's a full Linux computer with an operating system and everything. You just need to plug it into a TV set and a keyboard and a mouse, and you've got a computer. But you can do all these other things. People have made touch screens with it, home automation projects, digital cameras. Someone even made a working cell phone out of the Raspberry Pi. So another amazing prototyping tool that wasn't available 5 or 6 years ago, but has really sped up innovation and given people the power to make things. These are tools made by makers for other people to become makers of cool things. Am I doing okay for time?
You're doing great.
Okay, okay. So just about the mistakes. Like I said, mistakes are inevitable. Making things, designing things is an iterative process. And so with knowing that, get those mistakes finished early. And so, because also the more mistakes you make, the more innovative you become. So make a lot of mistakes, but do them early. And don't ever deliberately try to make mistakes, just accept them when they come as guidance for what you want to do. And here's an example of a mistake. I have this little espresso maker that I love, a stovetop espresso maker, in addition to the other one that you saw. And it has a handle, like a kind of a plastic handle that's resistant to temperature unless you have a 19-year-old daughter who leaves it on for an hour and walks away with the burner melting the handle off. So she like destroyed it. And so I was like so disgusted, I just threw the whole espresso machine into the trash. But then like a couple of hours later, I fished it out of the trash and I said, I'm going to make a handle out of the 3D printer. And so that little green plastic there's the little lid and the handle. I was so happy, I posted a picture on Instagram. I'm like, look what I did, everybody. And the second I made an espresso, the handle just melted right off. And I'm like, this sucks. But then so I was about to throw it away again, but I was determined, I have to make this work somehow. So I bought this set of, I had a set of 3 bamboo cutting boards, and there was like a little tiny one that I never used. So I just like drew a handle and cut it out with a bandsaw. And there's a bamboo handle, and that's just like a little scrap of wood for the lid. And so that has been working ever since. And I love, I actually think, that's why I'm saying mistakes are wonderful. I think that the one on the right looks a lot better than the one on the left. And if that had been a thermoset plastic that didn't melt, I'd still be stuck with the green one, but I'm so much happier with the bamboo one. And then funding. Before, when you wanted to make something, you had to secure funding, and it could be a difficult process. It would require lawyers and contracts, and you needed to, it couldn't be an individual doing that. So if you wanted to make something and actually sell it, you'd either have to have your family help you, or be independently wealthy, or crowdsourcing has changed all of that. And now, for this kind of certain spectrum of funding that you need, crowdsourcing fills that gap. So if it's too expensive for you to pay out of your pocket, but not worth like VC funding or angel investors, you go and get it crowdfunded. So the perfect one is like this thing called the Glyph. It's a tripod mount for your iPhone. So you can take movies on a tripod. They only needed $10,000 for the tooling, for the injection molding, but people liked it so much they got $137,000. That's like the perfect example of a crowdsourcing funding model. And then sales and distribution has changed thanks to the internet. I was asked to give an Arduino workshop at a makerspace in Los Angeles. And so I said, that sounds great. And the woman who runs the makerspace said, and I'm going to have an assistant, a guy named Quinn, help you during the thing, because there's going to be a lot of people there, and you can't like help all, you can't teach all these people without an assistant. I said, great. I said, I'll send Quinn my schematics of the electronic circuits and the code for the Arduino too. And so I sent them to Quinn, and he wrote back, and he redrew the circuits and modified the code and improved on it quite a bit. I'm like, thanks, Quinn. I thought he was like this college student. And when I got there, it was like this 12-year-old kid. And I'm like, Quinn, you're amazing. And not only that, but at that time, the same time, he had his own business called Q Techno, and he sells Arduino add-ons. And his parents are like, they're both pediatricians in San Luis Obispo. They're like, we have no idea what he's doing. So if you saw his company, the only way you would know he was a 12-year-old is that project, that little component on the bottom on the right, it's a fart sensor. So these are some what I call phase 2 creations. And if you look at them, they're like, these all happen to be made on I think this is the shape. This is the Shaper Origin, which is a little handheld router. It's really cool, about $2,000. But look at how nice these things look. I love the kind of the homespun look of Some make projects where it's like whittled and carved and kludged together. There's a certain charm of that, but you also have this option of making stuff that's super high-end and beautiful and would look great in any design within reach showroom. And it's gotten to the point, really, with these computer numerical controlled machines where it's almost like you can just draw parts and they come out of this machine. If you can use Adobe Illustrator to make a drawing of a shape, you can have something like this shape or origin routed out for you, and you end up with something this amazing looking. I just wanted to quickly go through some of these other kind of phase 2 making projects that are pretty amazing. This is a remote control cockroach, and you can glue it to the back of a cockroach, and then you put its antenna into some little probes, and then you take a radio controller, like the thing that you use to control remote control airplanes, and you can actually like steer the cockroach so it can like turn left and right. This is something that a friend of mine named Steve Hofer made, and he just did it quickly in a weekend. Those things are distance sensors there. He's got 2 distance sensors, and he has it hooked up to an Arduino, and then there's some cell phone vibrators in there too. So it was made for people with vision impairment. You can just like put it on your fist, and if you walk around, the closer you get to a barrier, like a chair or a wall or something, the more those little motors will thump. And this is something that he put together in a weekend. And it didn't take long to do, and the parts were under $100 to put this whole thing together. So imagine, like, what would this have taken required 15 years ago or 20 years ago? It really would have been a large organization. And this is a great example of what's happening to the disrupting organizations. OS Vehicles is a cool open source platform for cars where they make this kind of chassis here, and then you can put any kind of custom body on it that you want. And the final example I want to show is this device here. It's called the B-Geigy. It's a Geiger counter. So remember when Fukushima had the meltdown, Japan was not giving very reliable radiation reports. I think they just had a couple of sensors in the whole country, and they weren't taking readings often, and they weren't giving the reports to the public on a very consistent basis. So a hackerspace in Tokyo and hackerspace in LA got together, and they said, let's figure out a way to make this work. So they made a bunch of these things, and it's a Geiger counter inside there, an Arduino, and a Wi-Fi radio. And they made a bunch of them, and they gave them to people, and they said, hang these outside your car in a pouch, and then just drive around, and when you get home, bring the B-Geigy into your house. It will automatically upload all the data points you took. And so what it does is it just takes a Geiger counter reading every 15 seconds. And then it will, when you give this to a bunch of people and you ask them to drive around, you get this beautiful map here. This is a world map. On the right there is just a little part of Honshu. There's the yellow part is Fukushima. And so as people drive around, they collect all this data. So imagine if the Japanese government said, we want to make a system like this. How much money it would have taken, how much deliberations, contracts given, and everything. This was a group of hackers. They had some people kick in money, but really the whole thing was maybe $20,000 or $30,000 to do the whole project. And now these data points are used by scientists all over the world. They're accepted as really high quality data, and they're now doing similar sensing systems, these kind of citizen science distributed sensors for air pollution too. They're going to send one to me to monitor air pollution at my house in Los Angeles. I'm really excited to be part of that. So to wrap up, I like to show this guy. I've shown you all this like really cool high-tech stuff, all these great systems and manufacturing methods and tools and things like that. This guy, Scott Weaver, uses 3 things: knife, glue, and toothpicks. That's it. And this is a picture I took at Maker Faire of his creation, of his tools. And this is what he makes. This is 9 feet tall, and it's a map of 3D sculpture of San Francisco, and those are marbles down there. You can put marbles in one of 9 different pathways to take a tour through San Francisco. Coit Tower, Chinatown, the Transamerica Building, the Golden Gate Bridge, the Marina, Fisherman's Wharf. It's beautiful, and he makes these. He's a retail grocery store clerk in the East Bay, and he spends, as soon as he gets home from work, he's fully consumed with making his amazing toothpick sculptures. And as a result of showing his stuff at Maker Faire, where he's kind of unknown, he now has a permanent exhibition at the Exploratorium in San Francisco, and he goes in there almost every weekend and shows people what he does and helps people make their own. So when I was at Maker Faire, though, I said, Scott, I got to take your picture because I want to show people who you are. And he said, wait a minute. He said, hang on. And so he disappeared around like a partition at Maker Faire. I'm like, what's going on? And then he ran out and he said, okay, take my picture. So he is to me, represents what making is all about. All the technology and stuff is great and it helps and stuff, but you don't need any of it. You just need a glue, toothpick, and a knife. So that's it. Thank you.
Well, Mark, that was wonderful, and sort of certainly for those who are familiar with this world, it was exciting to see your vision of it, and for those who aren't as familiar, it was exciting to see. I'm sure it was exciting to see this fresh new world. So,
oh, good.
And Needy, do you want to sort of start off the Q&A?
Yeah, I don't know how many of you are familiar with the world, but for me, this was a delight to see Mark's view on the maker movement. I think you've seen from zines to open source, 3D printers or to the robots. And so I think I can understand that I come from that background and I can get on to the maker movement really quickly. I've been making, when I was at RISD, in architecture school, we made stuff with hands. I was surrounded by fine artists and they were making things. And then this change comes, and we are suddenly talking and interacting with engineers, and it feels like sometimes the design comes as an afterthought.
Mm-hmm.
So I think my question to you would be, do you see any systems where you have seen this connection between design and engineering work really well?
That's interesting. There's kind of a spectrum. There are people who are very design obsessed and they will very carefully, 3D model things. And then there's the other kind of group that is more about learn by doing.
Right.
And they're really interested in just doing a proof of concept prototype.
Mm-hmm.
Let's just see if we can make this thing work.
Right.
And I kind of felt, I wrote a book called Maker Dad about father-daughter DIY projects.
Absolutely, yes.
Okay.
Yes.
And one of the things I realized when I was making the projects in there was it took about 5 solid prototype levels to finally get to the point where I thought this was good enough to put in the magazine. And it was so interesting, you'd make your initial proof of concept prototype just to see if it would work.
Mm-hmm.
And then the second one you tried to do it as well as you could. Let's make a really solid thing. And in doing that, you would discover I should really do it this way. And this part is still structurally flimsy.
Right.
And each time you do the new iteration, it's a whole new vision of what you're doing unfolds. And so I think in a way that's kind of part of the fun of making,
Mm-hmm.
is that tinkering aspect and learning as you do. It's inefficient, it's very inefficient, but I think it's also very rewarding and a lot different from the kinds of activities that we're expected to do all the time. It's nice to have that freedom to explore and make mistakes and be inefficient. And I think it also is what gives us an advantage over this world where everything is going to be automated with AI and robotics, where efficiency and productivity is really important and being measured.
Right.
A friend of mine, Kevin Kelly's the thing that humans are really good at is being inefficient. And if you think of things like, science and exploration and inventing, those things, the waste to quality product ratio is really high. So maybe we should figure out how to be even more inefficient, you know, so that we can avoid the robot revolution taking over.
So you talked about a little bit about systems, and if you think of a larger sector of our industry right now, which is traditional, versus now the makers are coming into that realm, where hobbyists are becoming startup entrepreneurs. How do you think there are some lessons to learn for universities for teaching in terms of how these makers are genuinely using these systems, like R&D or prototyping or manufacturing?
I think so. I think, you know, the quick prototyping iterative process, being able to have on site the tools that you need to just like, let's see if this works,
Right.
like is really important. I think also learning to not be as centralized as possible, to be as decentralized as possible, and have like a really extended network of support, so that you have materials, source, manufacturing, all those kinds of things, not necessarily centralized and controlled by you as, you know, having to have an end-to-end solution for everything, but to have this network that you can dip into when you need it is less expensive, makes you more agile, so that you don't get locked into, you know, tooling costs and things like that. You can just like outsource those problems to everyone else and be stuck with the problems that are more interesting to you.
That's interesting, because when I moved to New York and we are trying to find this whole synthesis of what is maker space or a lab for Cornell Tech in New York City, right? And coming from the Bay Area, where I've seen many of these hacker spaces and maker spaces, which are open to university students also as other makers. But I feel like in New York, more than any other urban spaces, I think it has to be that decentralized, where you really you really make it happen in different parts, not just close to the universities or hacker spaces. It has to kind of come along.
Yeah, for sure. I think so. And there are, you know, there are so many services you can tap into.
Right.
You know, and you don't. Some of them are just like if you want someone to help you write some code or something, you can outsource that. You can get beautiful 2D laser cut parts made by a company called Pinoco, where you just send them the files. Shapeways can give you 3D printed things in super high resolution of everything from, you know, plastic to solid gold. And so having access to those things really opens up doors and opportunities that weren't inaccessible before. And I think that, you know, that those opportunities are as available and useful to the smallest companies or individuals to the largest corporations. They should all make use of the kind of maker innovations.
Right. I think the Pinoco meetup was my gateway to tech shop.
Oh, really?
In San Francisco.
Cool.
Yes. And I never left that place after that.
Yeah.
So definitely.
Pinoco is great. That's the second iteration of my peanut butter stirrer I made from laser cut bamboo parts that snap together.
That's awesome.
Yeah, I was happy with it.
That's awesome. So I'll let other jump in also,
Sure.
but I had one more, if I can dig your. So what do you think is the role of maker movement in economic development? Like, you know, how should we think about it in relation to like this big companies and startups?
Right. So economic, like you mean like the maker movement in the developing world, kind of?
Or in like today's economic.
Oh, in today's economic.
Right.
Yeah. I think that, you know, there's a lot to be gained from it, and I think that, you know, what happens is that a lot of people will make something cool, and they can have limited manufacturing here, but then they eventually go to China and other countries. And I think it is a chance to form good partnerships. And I'm seeing like such a strong connection now between the maker movement in the US and the manufacturing world in Shenzhen, where there are now, a guy named Bunny Wang has written a book actually on how to like go to China and find a ethical manufacturer.
It's an art.
Yeah.
Yeah.
And so there's great opportunities for that. And so I think that, I think that like high volume manufacturing in the United States is still not really possible. But I do think that the, partnerships with around the world
Right.
is going to be something that we're going to see continue to grow. To me, I think is really interesting. I think it's a positive thing, actually. And the idea of having to make there's handmade and then there's maker-made. And maker-made could be not that you're making everything yourself, but this whole network of makers around the world are working together to make things.
Mm-hmm.
Well, this is a great conversation. But I think everybody here has questions too. No, I'm fascinated. Do we have some questions from the audience before I take questions from online? Gentleman in the front, just wait for the microphone, if you don't mind.
Thank you for everything. I mean, it's really interesting to see, especially how trends repeat over time and how we seem to make the same mistakes and then realize their mistakes and then do it all over again. But what do you think the issue with ownership, especially with these crowdsourced projects?
Just put it closer to your...
If they do go to mass manufacturing and commercialization, the issue of ownership, how do you see that playing out, especially with, let's say a General Motors type company adopts something that the OS auto project created. What do you think that the challenges there are? Are there any precedents for made products going to manufacturing and then dealing with the IP?
Yeah, it's so hard, and I think for makers and small manufacturers, it's so tough to enforce. First of all, it's just hard to get a patent, and then to enforce it is hard. Do you know what, like the story with the fidget cubes, what happened? There's these little fidget cubes. They're like little plastic cubes that have like a wheel and a little button you can click, and it just, if you need to fiddle with something, it makes little popping sounds and things like that. So some people kickstarted fidget cubes, and I think they got like $4 million in funding, and they were like so excited they're going to make these fidget cubes. And before they even started making them, you could buy them on Alibaba for like $3. And so what happens is there's like companies, Chinese companies, that just troll through Kickstarter and Indiegogo and look at what's being kickstarted, and then before they even close funding, they're already selling them. And so how do you compete with that? It's like, I don't really know. And if you patent something, good luck enforcing that patent if someone takes it. I think, the model of open sourcing something is about as good as you can hope. Like Arduino, they open sourced the Arduino, the little prototyping board that I was telling you about, so that anyone can make an Arduino. They just can't call it an Arduino. And by doing that, they've kind of created, like, if you want a microcontroller, like Arduino is, that technology is the ecosystem for microcontrollers. Like that Quinn, the guy who made the fart detector, those are all Arduino components because they open sourced it. So as a result of that, even though Arduino does get ripped off and people make knockoff prototyping platforms called Arduino that aren't actually made by that company, at least there's a big enough ecosystem that people will buy enough of the original that they can stay in business. That's a tough thing. I mean, do you need the federal government to step in with trade enforcement and all that kind of stuff? Maybe so, but I think open sourcing your stuff and getting really passionate enthusiasts to embrace what you've done is probably the best you can hope for.
Mark, you were talking about the gift economy earlier. What did you mean when you said the gift economy? What is the relationship between that and what you're talking about now?
Yeah, in science fiction fandom, which like started in the 30s.
I have no idea what you're talking about. I've never read science fiction in my life.
So science fiction fandom is this, fans of science fiction, and You're just.
I was
teasing me.
joking,
You're
yeah, I
a
was
huge
joking.
science fiction aficionado.
Kim
Okay.
Stanley
Okay.
Robinson, yeah.
Okay. So in the 50s even there was this term called ego boo, and it's like if you do something really cool, bring like a great guest into a convention, or make a beautiful zine, or do something special. Like people, you don't get any money for it, but people are like, wow, they did something cool. It's an ego boost for you. And so the gift economy, part of it is the ego boo. You make something cool, other people recognize it, and I think it's that recognition that you help to contribute. And that, for a lot of these people, especially if they're not doing it for money, then, what else can you ask for than recognition?
Mm-hmm. Some other questions from the audience? Thank you.
Hi. I'm also from Cornell Tech. I'm really excited that you're here. Hi, Niti.
Hi, Diane.
So I work in a K-12 space, and we're really excited both to have Niti working with us and to think about the power of making for children.
Mm-hmm.
But I'm worried that we're not broadening participation outside sort of traditional hacker communities to get this to kids who are underrepresented in the tech world, in higher ed. Have you had any experience with trying to think about how we broaden participation to children, in economically vulnerable communities and kids of color? And
Yeah, I think, one thing to do is kind of like this outreach where hackerspaces, like the ones in Los Angeles, on weekends and certain nights, it's just an open door thing, and they encourage people to come in who have never made anything. And so I think that model could be extended by going into communities and making them aware of this opportunity. The LA Makerspace does have programs for disadvantaged youth to come and learn things like Arduino projects and making things like that. So I think that those kinds of programs are like a great way to get people to see what's going on. Like typically on these like kind of open houses at makerspaces, people bring the members show off what they have, the cool thing, and then they end it with like a little workshop where they'll teach soldering skills by putting together like a little circuit board that blinks an LED or something like that. And Maker Fairs do that also, where they on Fridays, the one in the Bay Area brings kids from all the school districts in for a day that's just open to the students, and there's tons of workshops and stuff like that. So I think just exposing people to what's available and can really turn a little light bulb on in their head.
Mark, you've talked about the Maker Faire a few times. Can you tell everybody what a Maker Faire is?
Oh, sure, yeah. The Maker Faire is like a huge science fair where it's not just students, but it's anybody who has an interesting project can go in and show what they have. So in a science fair, people have like a little table with their project on it. It's much the same at a Maker Faire. So they have people who have built musical instruments. They've had people who have indoor farming setups. They have people who make really cool kites, jewelry, anything that they've made. And so like the one in the Bay Area has 120,000 people come every weekend, and there's probably 3,000 or 4,000 maker booths set up. There's also a lot of workshops. There's talks, panel discussions, performances. A lot of people from Burning Man bring their giant sculptures and shelters into the Maker Faire and set them up in the parking lot there. There's also a Maker Faire at the former site of the World's Fair in Queens here. What's it called? The Hall of Science, I think. Mm-hmm. That's every fall. If you haven't been to a Maker Faire, you should really go and bring like your friends and family and kids. And it's an amazing experience. You'll be blown away by the stuff that people make. It's all like that, Scott Weaver's giant toothpick sculptures. There's stuff like that everywhere you look. It's pretty amazing.
Next person.
do you want to take one from the? You need a minute.
Well, no, we can take one from the internet. One of the questions is about these legal issues. I think it goes back to this question about IP. And I think that what is interesting, at least to me, is the maker movement seems to challenge so many of the built-in cultural and legal assumptions we have about production, about work, the purpose of work. The purpose of work is to, get paid. The purpose of work is to make something and sell it at scale. But there are real legal issues. What if you, like you were talking about your espresso pot, what if I downloaded an espresso pot and I set it to boil and it exploded and coffee got over me, right? And I burned myself. What are the sort of legal barriers to these kinds of issues of the sort of the gift economy in that way?
Yeah. I think, in a way, it's kind of people just rushed into this head first without thinking of these, and they're going to have to be settled. It's kind of in the way that, people started blogging and they never took any courses in journalism, so they knew nothing about libel laws or plagiarism or anything like that, and they didn't know that stuff was important, and then they started getting sued. And there's still problems with that. People write stuff online and they tweet, and all of a sudden they're hit with a libel suit. And I think that's going to take that's still not figured out. People are still not aware that what they say is they are responsible legally for what they say. So I think it's even more of a Wild West scenario in the maker world, and I don't know how it's I honestly don't know how it's going to shake out, but I do think eventually there will be lawsuits.
So I think hopefully what Cornell Tech is doing is going to facilitate that. So what we have right now is master students with the law tech for the one-year master program working next to a computer engineer and computer scientist starting their startup for the first time. So I think the merging pot of this whole tech education along the lines, because the ethics which we learn in any medicine or other areas or civil engineering or anything, I don't see that right now even in computer engineering or science. So let alone maker movement influencing this today's world of education so much. I'm hoping we'll have, the future law masters to address that.
I'm so glad you're working on that.
Yeah.
We really need
We're
it.
trying to. We're trying to, but yes.
We have time for a couple more questions. Yeah, the gentleman up front. Okay. Oh.
Hi.
Yes.
Hello. It sounds like the maker movement is for mostly concentrated of people who already have stable career paths or are just kind of looking for a way or an outlet to kind of let their creative being. What's the ratio of people using the maker movement and their investment in it to be more entrepreneurial and kind of start their own route versus just freelancing and making things on the side?
It's growing more in the direction of an entrepreneurial spirit. And I think that's one of the reasons is because it is becoming easier to make better stuff. And it's become more accessible for people who don't have a really developed maker skill set to get involved with making things. So I think the opportunities are growing, and at the same time the barrier to entry is dropping. So that's a good thing. In the early days it was just making things like the espresso temperature control system. There was no thought about commercial opportunities. It took a few years before somebody actually put together a kit to sell. So I think you'll see more and more people who dip their feet into the maker world, join a hacker space, realize what's possible, and then they'll have an idea and think, this thing I built, and other people have expressed an interest in it. Maybe could make this and sell it. We're going to see more of that happening.
And of course, the one I'm thinking about is I'm pretty sure the only electronics manufacturer in Manhattan is Adafruit Industries, right? That is one of the leading manufacturers of Arduino-related products, right?
Right, yeah.
You can probably tell the audience about that a bit.
Oh yeah. So Adafruit Industries is a hobbyist electronics kit company started by a woman named Lamore Freed, who went to MIT and then just started making little kits and doing videos online and showing its tutorials on how to do things with things like Arduino and new microcontrollers and stuff, and did such a great job of explaining and made such beautiful kits that everyone just gravitated towards her company and the product, the kits that she made. And so now it's, tens of $millions a year business. And they actually have such great, they are doing manufacturing there. They actually have the license to make the official Arduino boards there on the facility.
In Manhattan?
Yeah. Yeah, it's amazing.
I just want to emphasize that, because that's, to me, is like very shocking. As we
Yeah.
talk about all these things being shipped overseas, one of the things we're seeing is a lot of these industries are being done in our cities back home and reshoring, jobs and creativity and all these things.
Yeah, and that's like an amazing success story, Adafruit Industries, where Lamore was just kind of a hobbyist herself who was interested in this stuff and wanted to share it with other people, and they liked what she was doing so much, and they've just managed to scale up, and it's like, yeah, it's just shot up. And MakerBot was also a similar story for a while. They were, I think, were they in Brooklyn or were they?
We don't talk about Brooklyn and Manhattan.
Okay, okay, say
But
no
yeah,
more.
no, they were in Brooklyn, yeah.
Yeah, and so they were manufacturing. They kind of went on a different path and sold to a company, and it didn't end as well. But they still, if they had made other decisions, probably could have been making 3D printers to this day.
I think we have time for one more question, and then I think we should return to the food.
You started your conversation talking about repairs of farm equipment, and then you used that example of that television getting thrown away. And when you think about what might have been wrong with that television when it threw away, maybe it was just one small circuit that burnt. Where is the economic pressure going to come on the companies that are making our major durable consumer goods to produce them in a way that they are possible to repair in an economically viable way? Is there enough potential within the maker movement to put that pressure on to start, demanding that companies produce more sustainable goods?
Well, I don't know if this is going to exactly answer your question, but I think there are opportunities for manufacturers to tap into the innovation that the maker community can offer by making maker-friendly parts. So, like some products are made with like a little USB port that you can access that you have to actually open. But you can go in there and then you can modify it and stuff. And the companies can observe what's being done and the changes that are being made so that they can make modifications based on what these makers are doing to the parts, either what they want to do or what they're able to do. And so you could imagine, some kind of a product, a bicycle or something where it's easy to make changes, and the companies would be observing how those products are being modified. Just like the PID thing, they didn't watch, but it took, a long, long time, but they finally noticed. But if you make maker-friendly products, you might get this free R&D team of makers to help you make better stuff. And so I think, sadly, most people still are going to just want to buy solutions to their problems. Some won't, a smaller group will want to be contributors to the world around them and change it. So, yeah, I'm not completely optimistic that we're going to go back to the time where you can open up a fan and, replace all the consumables, the belts, and the motor burns out. Because it really is just cheaper to glue stuff together or press fit things.
Thank you all for coming here tonight, and thank you, Niti, for your great questions, and thank you, Mark, for your wonderful answers. All right, thank you.